Good day, everybody. This is Fred speaking. I hope everybody is doing fine. This is a tutorial, a short tutorial. Well, I'm gonna try to make it as short as possible. Well, I'm gonna do the same activity that we did in class. I'm gonna start by the first one that we did last Saturday. I'm gonna try to go very slow for those who had some confusion and for those who did not understand. Right. And for those who cannot meet during the week. Well, let's start. Well, this is our activity. Activity 1. You have this activity and you have the memo for this activity. Right. Here we have our activities, we have descriptions, the description of our activities, and we have immediate predecessors. Okay. And we are given the optimistic time for each of the activity, most likely time, and the pessimistic. Okay, and then we have our questions. First question is to develop a network for this problem, the expected time of each activity until the end, within what amount of time in weeks. Is there a 90% probability that the critical path for this project will be completed? In this tutorial, I am not going to explain the terms like critical path because I assume that we are all aware of those terms. Okay, so if anybody is lost with terms, he can refer himself to the book. Okay, let's start with develop a network for this problem. Okay, well, before going to the network, let me start with explaining what's happening here. So we're starting our project, right? Point 0. Okay, so this is the first day, this is the first activity that we're doing, build internal component. So immediate predecessors just means there's no other activity that sorry guys, there's no other activity that happened before activity A happened. Okay, it goes the same thing for activity B. Modify roof and floor. There's no other activity that happened before activity B. Alright, so activity A and B can start at the same time at point 0. So they're not depending on any other activity for them to start. Okay. Activity C, which is construct collection stock. This activity C can only start once we are done with building internal component. We cannot start activity C if we're not done building an internal component. And how do we know that? Because activity C has an immediate predecessors A. That way we say it. Okay. Activity D can only start after activity B is done. So immediate predecessors just means we can start these activities here where this activity here ended. Okay, well, let's go into practice. Okay, to answer our question 1. This is your network. So I did this network before. Right? So you don't want a messy network. You want a network that will be clean, that will allow you to proceed with all the other calculations. Okay, why am I saying that? Let's say, for example, you just draw your network and you take E, you put E right here, and you put F, let's say down here. That will be messy because you won't have a place to connect E and D to get a G. So I just hope this everybody understand this and it won't create any confusion or any trouble. Well, as I was saying, this is starting point where A and B came from. So they all starting here at point, let's say point 0, okay? And C starting where A finished, and D started where B ended. So D started here, and E and F started when we finished with activity C. That's why you're seeing E and F are connected to C. Okay, G here from E, H, H from F, and G. Well, and then we finish our network. So yes, this is question 1. Okay, I did this before just to avoid wasting time. Okay, but I really hope everybody understand this network and how we do it. Okay, and then let's go to question 2, which is determine the expected time of each activity. Okay, this tool, for us to determine the expected time for each activity, we will need our optimistic time, most likely time, and pessimistic time. Okay, so let's take this. Okay, P here. Well, this is what we have. We have our optimistic time represented by A, most likely time represented by M, pessimistic time represented by B. I believe a table like this should be given to you. Well, even if it's not given, well, you should draw it yourself. Sorry. Well, now we've been asked to calculate the expected time, and the formula to calculate the expected time is A plus 4M plus B. You divide everything by 6. Okay, so here it's gonna be 1 plus 4 plus 4 times 2. Here's 2 times 2 plus 3. Okay, everything we divide by 6. Divide by 6, and this is our expected time, which is represented by T. T equals, well, small t, 1 plus 4 multiplied by 2 plus 3 divided by 6. Okay, and we will do our normal calculations by math. So in mathematics, the rule is, if we have addition and multiplication in the same equation, we start by solving the multiplication. So we're going to solve this part first. 4 times 2 equals to 8. Right? And then it will be 1 plus 8 plus 3. Okay? Divided by 6. The whole answer you divide by 6, which shall give you 2. 2 here. Okay? Well, from there you proceed with the same calculation down here. Let's just do it one more time. T equals to T equals to true, which is A. Okay, 2 plus 3 times 4, okay, plus 4 B, right, plus 4, everything we divide by 6, which is equal to 3. Okay, well, yes, so we're gonna proceed with the same thing down here. So here we shall have 2, here we shall have 4, here we shall have 4, here we shall have 3, here shall have 5, here shall have 2. Okay, this is our expected time, okay, for each activity, right? So we've answered question 2. Well, I hope I am going very slow and nobody is lost up to now. Okay, so the third question is to answer is to find, to determine the earliest start, earliest finish, latest start, and latest finish. Earliest start just means the earliest moment you can start the inactivity, and earliest finish just means the earliest finish time you can finish the project. The latest start, the latest moment you will start the project, and latest finish, the latest moment you finished not the moment, not the project, your activity, right? So we've been asked quickly the earliest start, earliest finish, latest start, latest finish of each activity. And for us to find it, we're gonna go back to our network, this network. That's why you're seeing blocks here, right? Here we have our earliest start, okay, earliest finish, latest start, latest finish, okay. So this is gonna be the same for everything else. It's gonna be earliest start, earliest finish, latest start, latest finish, earliest start, earliest finish, latest start, latest finish. Okay, so and here we're gonna have our expected time, the one we have just done the calculation. Okay, here now here is our table. This here is our expected time, the t. Okay, this is our expected time, t. So these numbers are the ones that we gonna put here in our network, that up here, right up here. Well, let me change this color to, let's say, blue. Okay, so using these colors here, let's say blue. Okay, this expected time, that's the one we gonna put in our table. Okay, right here. So just I'm not gonna go in back there, but you have it. Okay, so here we had an expected time for activity A as 2, for activity B we had 3, for C we add 2, for D we add 4, for E we add 4, for F we add 3, for G we add 5, and for H we add 2. Okay, well, we have our activity. We have our activities here. We have our expected time here. Okay, let's just do this. This is our thing. This is our expected time. Okay, our expected time. I believe by now, yes, nobody's lost yet, and we know where we got these numbers. Okay, we know where we got these numbers. This is our expected time. Okay, now the next step is to compute our earliest start, earliest finish, latest start, latest finish of each activity. Okay, so let's go and answer the question. Yeah, so here it's the starting point. It's 0. Okay, this is 0. We're starting. This is the time. Okay, there's no time here. Time 0. Okay, and then activity A started at 0, at time 0. Okay, at week 0, at month 0, at year 0. Okay, whatever. Okay, sorry. And then here, the earliest start, the earliest moment for us to start activity A, it went 0. Okay, that's why we have 0 there. Well, this is too small. Okay, that's why we have 0 here. And the formula to find our earliest finish is earliest start plus expected time, which is t. Okay, formula to find earliest finish is earliest start plus t. This formula here, earliest start plus t gives us our earliest finish. So right here, sorry, right here, so we're gonna have 0 plus 2, which will give us 2. Okay, let's make this one a little bit big. Okay, 0 plus 2 gives 2. Okay, and for activity B, also start at point 0. Okay, we have 0, 0 plus 3, earliest start plus earliest finish, which will give us 3. Okay, well, let's go now to activity C. Okay, our earliest finish of the previous activity, okay, of this activity here, will be our earliest start for our next activity. So when we were, let's say this, when we were building our internal component, okay, we started at time 0. All right, and then when we finished building the internal component, we finished building it in weeks 2, and from weeks 2 we started C. Right, we started to construct collection stack. So that's why here C is gonna have 2 as its earliest start, because we are done here with A, and we proceed the same thing. 2 plus 2 it expected time, which gives us 4. Okay, sorry, gives us 4. Okay, and for D here, D will start where B ended. For B, let me just do this one more time. B, modify roof and floor. Okay, this activity here was done in the 3rd week. Okay, and in the 3rd week we can start our activity D, pro contract and install frame. Okay, well, hope no one is lost up to now. So here the earliest finish here is going to be our earliest start here. So give a 3. 3 plus 4, that's the expected time for D, 7. Okay, everything is fine. Now for E and F, okay, Our earliest finish time for C was 4. So 4 is gonna be our earliest start for F, 4, and our earliest start for E, 4. Why? Because both activities are connected to C. Okay, both activity are connected to C. All right. And then let's just do 4 plus 3, which will give you 7, and 4 plus 4, which will give you 8. Okay, sorry guys. Okay, 4 plus 4, which gives us 8. Well, we proceed with the same process. Now here we have D and E. So G is connected to E and D, right? When going back, so this activity here can only start once E and D are done. Okay, so which means these are the times for activity D, and this is the earliest finish for activity E, and this is the earliest finish for activity E for activity D. Sorry. Even though G can start when E and D is done, they are not done at the same time. They don't have the same earliest finish. But it is recommended that we are going to start G after both activities are done. And we can see that D is done earlier than E. Okay? So E is done later. Okay? So we can only start when both activities are done. So because of that, we're going to take the highest number, the highest time, which is E, because this one is done already and this one is not done yet. By 7, this one is not done yet, so this one is going to be done by 8. Okay, so that's the reason why I'm going to take 8 here, 8 instead of 7 when going forward and meet a case like this. Okay, at this point we take the highest number, that's why we're taking 8 here, and 8 plus 3 plus 5, sorry, it should give you 13. What just happened? 13. Okay, and H right here, it's from F and G, so the same case happen again. H is only starting when F and G is done. Okay, so here we'll have 13. Okay, so 13 plus 2, which will give you 15. Okay, we are done with our earliest start, earliest finish. So we're going to take these numbers, this earliest start, earliest finish for each of the activity, and put it in our table right here for both. So just to save time, we know them already. Okay, so here for activity A we have as our earliest start 0, we have 0 here. For B we have 2, for C we have 3, we have 4, we have 4, we have 8, and we have 13. Okay, and then for our earliest finish, we have 2, we have 3, we have 4, we have 7, we have 8, we have 7, we have 13, and then we have 15. So we are done with earliest start and earliest finish. Okay, now let's go back to latest start and latest finish. Okay, wow. Okay, for us to do our latest start and latest finish, um, our last earliest finish, okay, here in H, it's gonna be our first latest finish in H. So this 15 here, it's gonna come down here. So when going forward, okay, when going forward, we're starting by here, right? By the first, let me call it first block or first square. Okay, right. We're starting right here. But when going backward, we start at the back. Okay, right here, 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 and right there. Okay, that's where we start, and we finish here, 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 and there. So the formula for us to find, um, let me put it this way. Let me put right here, as we have our latest. We have our latest finish right here. Sorry. We have our latest finish. Okay, and right here we have our latest start. Okay, and to find our latest start, the formula is latest start equals to latest finish minus t, which is our expected time. Okay, no, here. Okay, 15 minus 2 was for our latest start. 15 minus 2, which is 13. Okay, sorry, just make it a little bit cleaner. Okay, so 15 minus 2, which gives us 13. So this 13 here is the one that's gonna go here and here, because we're going back. So 13 will be here, 13 will be here, and 13 will be there, because that way this is our latest dot. Our last latest dot, it's gonna be our next latest finish. Okay, here. So we're going backward, and to find again our latest dot for G, it's gonna be 13 minus 5. Okay, which gives you 8, and 13 minus 3, which gives you 10. Okay, well, 8 it should give to E and D, right? So it is gonna be 8 here, 8 here, and 8 right here. Okay, so it's gonna be 8 minus 4, which gives us 4, and 8 minus 4, which gives us 4. Okay, now we get to a situation when going backward, these two has to give one of them, of these two have to give to C. Now when going forward, remember we took the highest number. Okay, for this case here, it was 7 and 8. Okay, we gave G8, but when going backward, we'll take the smallest number. So 10 and 4, we'll take 4. Okay, and then we proceed with the same process. 4 minus 2 should give you 2. Okay, and 4 minus 4, no, sorry, 4 would give here to 4, not 4 minus 4. Okay, 4 will give here. So we have 2 here, which will give to this one 2. Okay, 2. Okay, 2 minus 2, which end with 0. Okay, and 4 minus 3, which change to 1, is our latest dot. This is how we got our numbers. Wow, hope nobody's lost. Okay, now we take these numbers, latest dot, let's finish for each activity, and we complete them in our table. So we have 0 here, we have 1, we have 2, we have 4, we have 4, we have 10, we have 8, and we have 13. Okay, then here we have 2, we have 4, we have 4, we have 8, we have 8, we have 13, we have 13, and then we have 15. Okay, right, we have answered question 3. Okay, I hope I'm slow enough, and like me, this is a video. If you got lost or confused somewhere, you can always go back. Okay, we've answered our question 3. Now the question 4 says the slack for each activity, and which activities has slack, and which ones don't have a slack. Okay, this is a formula for slack. Slack equals to latest start minus earliest start, or latest finish minus earliest finish. Either of the formula is going to give us the same slack, the same answer. If you do this, but it gives you the same, it gives you a different answer from doing this, then you must be wrong somewhere in your network. Okay, so to complete our slack, we're gonna do it from our table. Okay, okay, let's answer first part of question 4. So it's gonna be latest finish minus earliest finish, or it's gonna be latest start minus earliest start. Okay, so 2 minus 2 gives us 0. Okay, and then 4 minus 3, or 1 minus 0, gives us 1. Okay, and then we have 0 here, then we have 1 again here, then we have 0. Well, 13 minus 7, or 10 minus 4, gives us 6. Then we have 0 here, and then we have 0 here. Okay, we've answered the first part of question 4, the slack of each activity. Okay, now which activities has slack and which ones don't have slack? The activities that have slack are those activities that have 0 as slack. Okay, and activities that don't have slack are those activities that don't have 0 as slack. Okay, now let's do it here. Well, let me do this. Insert another. Okay, So we're just gonna put yes, no, yes, and no, represented by y and n. So activity A, yes, it has a slug. Activity B, no, it does not. Activity C, yes. Then we have no, we have yes, we have no, and then we have yes and yes. So here, this true here, we've answered question 4. We've answered question 4. Okay. Okay, let's do this. Well, you can write down here. Well, this activity, right? Just put it here. Activity that have like are called critical activities. Okay. Critical activities. Critical activities are A, B, A. We have A, B, alpha, F, G, and H. Okay, these are our activities. Just confirm one thing. We have A. Okay, we have C, not B. Sorry, excuse me, because it has 0 here. And then we have okay, I think there's some confusion here. Sorry guys, sorry. It's A and then B. Okay, then B, then C, D, E, alpha, G, and H. Okay, so don't worry, everything here is correct. We just here. Sorry. So critical activities will be the ones that have a zero slug. We have A, we have C, we have E, right? We have G, then we have H. Okay, then we have H. So these are our critical activities, right? And in other term, this is called our critical path, right? So A, C, E, G, and H are is our critical path for this project. Okay, by now I believe we know what is critical path is, and we see it is our critical activities. Okay, let's go to the next question. Next question is the variance of each activity and the project variance. Okay, to calculate the project, we'll go into our table. Formula to calculate the variance is B minus A. You divide everything by 6. Then you all answer, you square it. Okay, the formula will be given to you at the test. B minus A divided by 6, and then you square everything. Well, you have your calculator. You first deal with A minus B. Then the answer you divide by 6. Okay, and then everything is squared by 2. Okay, well, just to save us time, you should get here 0.11, here 0.11, here 0.11, here 0.44, you should get 1. Here you should get 0.777, but you run it off, which should be 0.78. Here to be 0.78, and here to be 0.11. Okay, this is our variances for each of the activity. Okay, and then the next question is, okay, next question, no, we still at question 5, variance of each activity. We've done it. Okay, and the project variance. The project variance is just gonna be the variance of the critical activities. Well, we're gonna add variance of the critical activities. Okay, so it's gonna be, let me look at a formula. This is the formula for project variance. Project variance equals to the sum of the project variances. So let's go back here, right here. This is the critical activities, and this here is a critical path. So variances of the activity on the critical path. Okay, let me write it down. Project variance equals to sum, okay, the sum of variances of activities, variances on the critical path. On the critical path. Okay, critical variances. Okay, so the sum of variances of activities on the critical path. So project variance project variance, it equals to, we have it gonna be the variance of activities on the critical path. This is activities on the critical path, as called the critical activities. Okay, so their variances are, for A it's 0.11, plus we're gonna take for C here 0.11, okay, plus for E plus 1, plus G, okay, 1.78, plus H plus 10, okay, 1.11. So this one here is our variances. Okay, let me just do this. Okay, do this. Let me just do this. We have this one. We have this one, and we have this two. Okay, so these are critical activities, or the critical part of the project: A, C, E, G, and H. So these variances, the answer here should be 3.111. Okay, project variance. This is your answer for project variance, and we've answered question question 5. Okay, now let's go on to question 6. Right, the standard deviation of each activity and the project standard deviation. Okay, well, this is the easiest one. Okay, because the standard deviation, its formula is just the square root of the variance. This one, the square root of the variance, which gives you the standard deviation, and this here is the symbol or the sign for standard deviation. So if we do the square root of 11.11, let me try to put it in a formula. Well, equation okay, of 0.11 should be equal to 0.33. Okay, so this one here is this our variance, and this is our standard deviation. So for activity B, it can be the same thing: 0.33, 0.33, 0.661, okay, 0.88, 0.88, and 3.33. So we've answered a part of question 6, standard deviation of each activity. Okay, hope all slow enough. Well, the next second part of question 6 is the project standard deviation. Now, to find the project standard deviation, it's not going to be like we did for the variance. We are not going to add the standard deviation of the activities on the critical path. No, that's not going to happen. So the standard deviation for the entire project is going to be the square root of the project variance. This is the project variance. Okay, this is the project variance right here. But let me just go back. Okay, this is the project variance. And now the standard the project standard deviation, project standard deviation is the square root of the project variance. Okay, which should be the project standard deviation equals to square root okay, it can be square root of 3.111, which should be equals to 1.76 weeks. Okay, so here we've answered the second part of question 6. Okay, project variance. Okay, yes, the project standard deviation and the project standard deviation, which is the square root of our project variance. Okay, now let's go now to question 7. Sorry, just check this one quick. Okay, go now to question 7. Now they're asking to determine the probability that the project will finish on or before 16 weeks. Okay, on or before 16 weeks. Okay, so okay, there's one question that's missing amongst this question. Let me just put it right here. 7, question 7. Okay, what is the project? It's a project completion time. Okay, or the project expected expected completion time. Okay, so if they ask this question, what is the project expected completion time, or the project completion time? The project completion time is this one. This is the project completion time, 15. Okay, so oops, sorry, wow, Ibra. Okay, sorry guys. Okay, this 15 here is our project completion time. This, so this entire project is gonna run for 15 weeks. Okay, now your last time here, your last number here is your project completion time. You are expected to finish the entire project in 15 weeks. Okay, so let's go back here, and then where do you see that number again? You see it right here. Let us finish. This one here is our expected completion time. This one here. Okay, well, and then sorry guys, okay, now let's proceed with our questions. I believe we've answered question 7. Now let's go to let me now answer question 8. The probability that the project will finish on or before 16 weeks. So you already have your expected completion time, right? Now you've been asked what is the probability that the project will finish on or before 16 weeks. All right, that's the question the manager is giving you. He could have asked you what is the probability that the project will finish on or before, let's say 17 weeks, 18 weeks, 19 weeks, 20 weeks. All right, or you could have asked what the probability that the project will finish later or on 16 weeks, 19 weeks, 20 weeks, and so on. Okay, but this question says what is the probability that the project will finish on or before 16 weeks. So if you remember from our last class, that's where we're going to include z, the z value. Okay, z value. So we're going to put it in a formula, z value. Okay, z equals to due date minus expected expected date of completion, the date of completion, then you divide everything, right? You divide the whole answer by the standard deviation, and a symbol for standard deviation is this one. Okay, divided by standard deviation. Okay, so due date minus expected date of completion divided by standard deviation. Okay, so if we have to apply the formula, the due date is the date that is given to you, right? 16 weeks. Remember 16 weeks? Yes, 16 weeks. This is the due date that we're given. Okay, this, okay, here, and our expected date of completion, remember, it's 15 weeks. This is our expected date to complete our entire project. Okay, and our standard deviation for the project, okay, is 1.76 weeks. Now we have everything. Let's just put everything into the equation. Okay, z equals to z equals to due date, which is 15. Okay, 15 minus 16. Okay, minus 16, and then you divide everything by 1.76. Okay, okay, this is it, right? 15 minus 16, you divide by 1.76. okay, when you put it in a calculator, your answer should give you 0.57. okay, now this is not what do you call it, this is not a probability that the project will finish on or before 16 weeks. No. Okay, after getting this answer here, we go to our normal table, our normal distribution table. Okay, sorry, I did not open it. There it is. Okay, our normal distribution table, it's gonna be this one, area under the standard normal curve. So this table here will be given to you. Okay, this table here will be given to you. So we are going to use this one here, this one, this table will be given to you at the test. Okay, so we are going to look where in the Z column and in the Z row. So this row here, the first row here, represent the second decimal place in Z, and this row here represent the first decimal place in Z. Remember our Z value? Our Z value is 0.57. So 0.5 is our first decimal place, and 0.07 is our second decimal place. Okay, so let's go back to here. So here in our Z column, just find 0.5, which is this one, 0,5. Okay, 0,5. Okay, and here we just look for 0,07. Okay, these are our numbers. So 0,5 plus 0,07 should give you 0,57. Okay, and where they intersect, like here, 0,5 come across the row, 0,7 down the column, 8 here. So this answer here, 0,7157, is your probability. Okay, so in this case, just means let's see, the probability to complete the project on or before 16 weeks is 0.757, or else you just take 0.57, I mean 7157 times 100, sorry, times 100, times 100, which should give you 71.57%. Probability is expressed in percentages. So that's your answer. The probability that we complete the project on or before 16 weeks is 0.7157 or 71.57%. Okay, we've answered question 8. Okay, now the last question, question 9. Within sorry, what amount of time in weeks, okay, is there a 90% probability that the critical part for this project will be completed? Sorry, what here we can see that we are given a probability already. Remember here we were looking for a probability, okay, but now here we are given a probability already. Okay, so just gonna be this gonna be, we have 90%. Okay, we have 90% given to us. 90%, as said, at 90 you divide it by 100. Okay, so that we go back to the original form. Okay, so 90% equals to 0,90. I mean 0.90. Oh, let's see, we did 90, we divided it by 100. Okay, which give us 0.90. So we have this. Okay, we have this. This is what's given to us. Now we've been asked, right, 90% probability. Okay, so now the question is, within what amount of time in weeks? We are looking for it in weeks. Okay, is there a 90% probability that the critical part for this project will be completed? Okay, let's go back just a little bit. Remember here, right, for us to get this answer here, we did the expected did a confusion here. I did a mistake. 8:15. I'm so sorry about that. So it's 16 minus 15. The due date given to us, due date 16, which is given to us, minus the expected date of completion, 15. Okay, so sorry about that. So it's gonna be 16 minus 15. That gave us 1 divided by 1.76 give us 0.57. Okay, now if we have to go back here, remember this answer here. For us to get this answer, we went into this table and we did 0.50 0.5 plus here 0.07, which give us this percentage here, this probability here, right? Okay, now to answer our last question, we are already given this 0.90. Now we have to find the z value, which we don't have. Okay, so in this case, we're gonna go back in our table and look where 0.90 appears for the first time. Okay, so this is, sorry, this one here is our table where that 0.90 appears for the first time. Remember, we are looking for the z value, and z value, this here the second decimal of z value, and this here the first decimal of z value. So 0.90 appears here for the first time. Okay, this is 0.90 appears for the first time. We see 0.9015. So we're gonna look up in the column. The second decimal place in Z is 0.09, and we're gonna follow the row at 1.2. So we are going to add 1.2, okay, 1.2 plus 0.09, which should give us, so we are going Z equals to 1.2 plus 0.09. The answer should give you 1.29. So this one here, okay, is our z value. This is our z value. Now if we have to put everything in this formula here, remember, what are we looking for? This, the due date. Okay, let me just go back a little bit. So within what amount of time in weeks? This amount of time in weeks, we are looking for a due date. Okay, so I do it here. It's gonna be 1.29 equals to, we're just putting everything in this formula. We don't have the due date, so let's say the due date is x, because we don't know what is it that what we are looking for. It's gonna be that minus, let me put in an equation. Okay, so it's gonna be 1.29 equals to x minus expected date of completion, which is 15. Okay, and then everything we divide it by 1.76. I mean 26. Okay, so this here, this is how our equation should look like. Okay, we have our z. We all know how we found our z. We had 90%, we put it in 0.09. We went into our normal table and we find where 0,90 appeared for the first time, and we saw it was 0,9015, you're not gonna take this number, right? You just take up, look up here in the z, second decimal place in z, it's gonna be 0.09, plus you look across the row until the end to see the z, it's gonna be 0.2 with 1.2 plus 0,09 gave us 1.29. So we're putting everything in this formula so that we may find the due date, or this the probability that the project will finish within what amount of time. Okay, so this is the amount of time we are looking. So here we're gonna do what we called cross multiplication. Okay, so in the note that I sent, I put the formula for the due date, but on the test you're gonna be given this formula exactly like this. So cross multiplication works like we are going to multiply 1.76 by 1.29 and 15 minus x minus 15 multiplied by 1, because we assume 1 is here. So cross multiplication goes like this here and this here. Okay, now let's do it. Well, trying to explain this easiest way possible. So it's going to be 1, you multiply it by x minus 15, okay, which is equals to 1.29 multiply by 1.76. Okay, and here 1 multiplied by this should give you 1 multiplied by any number gives that number, so it's gonna be 1 multiplied by x minus 1 multiplied by 15, which should give you 50x x minus, let's put it in the equation. Okay, it's gonna be x minus 15, which is equals to let's do this 1.29 multiplied by 1.76 gives me 1.29 multiplied by 1.76 gives me 2.27. Okay, and now from here we put the unknown x in one side of the equation, we leave it there, and then we take 15, we bring it back on the other side, right? So if we take minus 15, this is a minus 15. If we take minus 15 and we bring it this side, it's gonna have a positive number. Okay, so it's gonna be 2.27, our 2.27, and we take the 15, we bring it this side, it should give us plus 15. Okay, and the answer should be 17.27 days. Okay, we've answered this question here. Within what amount of time in weeks? So this one too should be in weeks. Within what amount of time within what amount of time in weeks is there a 90% probability? So this is our answer. First one here. 17.27 weeks. Well, I think we've reached the end of our tutorial. We've answered question 1 to 9. Okay. Well, I really hope I was slow enough, and I really hope this tutorial is gonna be very beneficial to those who did not understand, or those who had some confusion, and those who don't have the possibility to meet on campus. Well, I've sent you guys another activity. Okay, I've sent it another activity. It's not a similar activity. I'll send a tutorial for that activity and the memo for that activity on Thursday. Okay, well, I will do the same thing that I've been doing here. Okay, just if you don't understand anything, recap the video and restart at fresh. Once you've mastered this, I think I can guarantee that you'll be fine for the test. Okay, this activity, the second activity that we did on Saturday, and the third activity that I sent you guys, that activity, the one I was sending them on Thursday. Okay, so I think we've reached the end of our class. Of our tutorial, of our video. And if you have any more questions, don't hesitate to contact me. You have my contact number, and you also have my email address. If there's any question, please let me know. And if there's some confusion, please let me know. Well, thank you very much, and best of wishes to you all for your test.